I've now got this set up as a parallel circuit. So here our three resistors, A, B and C, are arranged as you can see. So what we've got is a situation where the potential difference, the voltage, is the same or should be the same across each one of these resistors. So the first thing I'm going to do is measure the potential difference across the whole circuit. So turn it on first of all, connect this up, plug this in, and read there a potential difference of 10.5. Let's call that 10.5. It's changing a bit, so okay. Now the potential difference across each one of these resistors, so I'll just plug those leads in. So we'll start with A. So the potential difference across resistor A is 10.0, let's call that 0.5. Okay, let's try the potential difference across resistor B. Our potential difference there is a reading of 10.3, and taking this out and plugging it in here to get a potential difference across resistor C. We get a figure there of 10.4, we'll call it 10.45. Now, to measure the potential difference across all three, I'll plug it in here, which I think I did earlier. And now a reading of 10.6. Let's call it 4. So the next thing to do is to look at the current. So I'll disconnect this here and set this up as an ammeter. Now that this multimeter is set up as a ammeter, our job is to measure the current, first of all going through the whole circuit. So turn this on to begin with. And what I've got here is I've got it connected so that the current goes through here, and then it can branch, run through there, and then come back to here. So our total current there is 3.59 amps. So we'll just rearrange our circuit. I'll disconnect this and put that back, so everything now is in parallel. And what I want to do is measure the current going across. Well, I'll start with A, and to do that what I'm going to do is disconnect this, plug that into here, plug this into here. That is extremely hot. And you can see there that I've got a current of 1.93 amps. I'll just turn this off so it cools down a bit, and I'll swap this over then, and we can connect this up to the second. Okay, So disconnecting this here and reconnecting this, plugging our ammeter into here, and then this part of the circuit into here for our ammeter, and turning then our power pack back on, and there we've got a current of 0.99 amps. Okay, so we turn that off and let the resistors cool a bit. Disconnect this and disconnect this so that this can be connected back to here. And what I've got then is a circuit now that's complete, except I do need this lead. So I've got all of those back in parallel now, and I can connect the ammeter across C, sorry, not across C, but in this way, so that the current is measured going through C. Plugging that in there, turning our current on, and there we've got a current of 0.68 amps. Here's a table that you can use to record your data and record your calculations. Then compare what you got with what is expected using the equations that theory suggests that you should get from an experiment like this. And if there are differences, then have a look and see if you can work out just what might account for those differences. Particularly keep in mind the fact that usually with electrical connections and the plugs that we had there, you're going to get a little bit of resistance. Now, one of the odd features that I found in this was the initial measurement of the total voltage compared with the final when I did it the second time. It was different. Interesting question is, what might account for something like this? So when we do actual experiments and compare them with what we expect, often we can make some progress or learn something. I hope you do.